The topic for today's video is X-rays, and we are going to look at some of the benefits of using X-rays compared to some of the drawbacks associated with their use. Now, the first thing to probably do is remind ourselves of what X-rays are, and they are part of the electromagnetic spectrum, something that we've studied in a previous video, and they sit between gamma rays and ultraviolet radiation, and they have a certain wavelength associated with them. It's a very short wavelength, and what we can do is just take out that little range of X-rays, and while the wavelength is very short, there is still some level of variation in those X-rays. So we have shorter wavelength and higher frequency X-rays, and we also have some slightly longer wavelength and lower frequency X-rays, but remember that they have all a certain wavelength, and that wavelength is very short, and it's actually round about the width of an atom, or the order of magnitude or order of size of an atom. So here's a rather badly drawn sketch of an atom, but if you look at the wavelength, you can see it's round about the size of this atom, and that's a key point that you need to remember. The second thing is that they cause ionization, and by ionization, we have studied this in a previous video, but by ionization we mean that they can actually knock off electrons from atoms. So if I've got an atom here, here's an electron, these X-rays can actually cause these electrons to be knocked off, and that will ionize this atom. This is a particular problem if the kind of atoms that are ionized are in the DNA, and this can actually lead to cancer. It's actually quite interesting to note that X-rays can actually be used in the treatment of cancer as well, a bit like gamma rays, but they can also cause cancer as well. The next point is that they affect photographic film in the same way light does, and we'll look at that in more detail in a moment. And the last point to remember is that they are absorbed by metal and bone, and we're going to look at these last 2 points and see how they're actually used in terms of looking for potentially broken bones that people might have managed to get. Now here is just an example of the use. Here is our arm that has a suspected breakage, and behind the arm is some photographic film, and the photographic film starts off as being white, but anytime it's hit by an X-ray it will go black. So if X-rays are fired at this arm, everything that is turned or is hit by the X-ray will turn black. The parts that are not reached by the X-rays stay white, and the reason the X-ray might not reach the film is because bone is in the way, and as we said, the bone can absorb the X-rays. So if we were to see what the result would look like afterwards, here we go, that's what it might look like. Let's just remove the arm as well. You can see there that the X-rays have very clearly hit all this area that's turned black, but the parts that have absorbed the X-rays have stayed white, and this then gives us an image that we can use to look at, and we can see in fact this arm does have a breakage right there. It can be used similarly with looking at teeth. So here is an X-ray of some teeth. The white areas is where the X-rays have been absorbed by the teeth and some of the firmer tissue in the gums, but you can see this person here actually has a bit of a cavity in this area here, and the dentist can actually then use this image to decide on the correct treatment. The next use of X-rays I want to look at briefly is the idea of CT scans, and CT just stands for computerized tomography scans, and the way this works is that we have a machine that's basically like a tube. A person would be inserted into the tube, and we have an X-ray emitter here, we call it an X-ray tube, and this will emit X-rays in this direction, and what we can do is we can actually rotate this whole tube like so it will emit the X-rays towards the person in all directions in the full 360 degree turn. Now if we have our person here in the middle, you can imagine that if this X-ray tube goes all the way around, it will take an image from every direction, and what we can do next is connect it to something that we call a charge coupled device, and this basically converts the X-rays into light so that we can produce a digital image on a screen of what we see. Now the great advantage of using CT scans is that it can produce a much more detailed image. It can produce a 3D image of an organ, and it also can distinguish between softer and harder tissue, so you can actually see the difference between those two types of tissue. Now, with both of these types of uses for X-rays, there are some safety issues. So what we have to take into consideration is that if X-rays are given to somebody on a regular basis, as we said, the ionization can cause a problem and it can lead to cancer. So there's a couple of safety points that we have to put into place. The first one is the use of lead shielding. Lead is a good absorber of X-rays. So lead absorbs X-rays, and therefore if you're standing behind it, you won't actually get a dose of the X-rays. So anybody working with X-rays on a regular basis should really stand behind lead shielding or lead glass to make sure they don't get a dose that's too high. The second way in which people are protected is by using what we call film badges, and this is basically a badge. You can see the size of it. There's a safety pin on the side there, and this is worn by people who work with X-rays, and there's a film inside here. Is a plastic casing so that the X-rays can actually get through, but it's a plastic casing with film inside, and this can be checked on a regular basis to see the amount of, or the dose of X-rays that have been this person has been exposed to, and if it's too high, obviously they need to be removed from that environment. The last thing I want to look at quickly is comparing CT scanners with X-ray machines, and when we're comparing, remember this is a command word, we have to look at the features of one compared to the features of the other. So with CT scanners we have a higher dose of X-ray radiation that is given, whereas with the X-ray machines it's a lower dose. CT scanners can produce a 3D image, on the other hand X-ray machines produce a 2D image. CT scanners can distinguish between soft tissues, so different kinds of tissues can be differentiated with our CT scanner, and the CT scanner is a bit more expensive, or quite a lot more expensive in fact. The X-ray machine on the other hand is much cheaper. So you should be able to compare the two different systems or the different uses of X-rays by looking at these points here, and that's basically an overview of the use of X-rays, some of the dangers and what can be done about them. That's me done for this video. Thank you for watching, and I'll see you again soon.